All right, moving right along into 5.4, solving compound inequalities. Okay, so today, really one objective, multiple parts to it though, but one objective is to solve compound inequalities containing the word and or, and then graph those solutions on number lines. Okay, so that's what we're going to be working on today. So what is a compound inequality? It's simply two or more inequalities that are in one problem. Okay, so we might see things like x is less than 3 and x, let's just say, and x is less than 9, which means that x is, I shouldn't say less than here, x, well, let's just say x is greater than 3 and x is less than 9. Okay, so if I have two inequalities like that, it's just telling us to look between 3 and 9, right? So, you might have certain word problems where you just want to look at a range of numbers between two numbers. And when we do that, we use a compound inequality. We also have some possibilities when we use the word or. So maybe we want one thing to happen, or if we get to a certain level, we want something else to happen. That would be a reason that we would use a compound or inequality. Okay, so I'll show you guys how these show up here in the first couple of examples. An intersection on these graphs is just where the two graphs cross. Okay, so and statements, if you have an and statement is looking at where the intersection is, where the two graphs cross. So most of the time, actually all of the time, when you're going to graph an and statement, it's going to be a solid line between two numbers. On the flip side, for an or statement, or statements will typically go off in opposite directions. It'll be something like this on a number line for or. All right, and again, I'm going to show you why that is and how that shows up here. So let's look at and inequalities. So, like I said, these things happen when you want to look at a range between two numbers. So in this case, they're saying, okay, what happens if x is greater than 2? All right, so let's take a look at that. I'm going to label this whole number line. And for today, you guys, up until this point, I've been having you guys basically just jot down 1 or 2 points on these. For today, you need to label these number lines a little bit better. Okay, so let's just put 0 right here. All right, and then we'll do 1, 2, 3, 4, 5, 6, 7, 8. Okay, if x is greater than 2, if I'm going to graph that, I have an open circle here going off this way. All right, and if I were to graph this one separately, x is less than 6. Let's use the exact same scale. All right. Okay, so if I said x is less than 6, then at 6 I would have an open circle. I would be going this way, right? Okay, so if I had an and inequality and said, okay, x is greater than 2 and it's less than 6, then what I look at on the graph, if I were to graph them together, which is what you're going to be doing today, all right? Just wanted to show you that individually first. If you have this and statement, it's saying that the graph is going to be between 2 and 6. It's going to be greater than 2, right? And it's going to be less than 6. So it's the place where, I'll show this to you here, it's the place where you have this overlap, right, between 2 and 6. So you would just shade or draw your line between the 2 points. That's what an and inequality really is. Okay, so here's an example of one of them. They're going to make you do a little bit of algebra first to solve this. Okay, so you're using what you learned in lesson 1 and lesson 2, and lesson 3, I guess. And then once you have your statement, then you're going to graph it. Okay, so let's look at this. If I want to get y by itself here, I need to add 3 to both sides. And then I'm left with y is greater than or equal to negative 8. And then here, I'm going to do the same thing, add 3 to both sides. And I have that y is less than or equal to negative 5. Okay? And it's joined with the word and, right? So we know that the y value, okay, so it's kind of nice to make a compound statement. I don't know that they're going to make you do this, but I like to make a compound statement. So it's saying y values are greater than negative 8. So we're going to start at negative 8, and the alligator is going to eat, notice it says or equal to, it's going to eat the y, okay? And then on the other side, we have negative 5. So it's saying the y value is between negative 8 and negative 5. All right, so if I go to graph this, let's just go like this. Negative 8 is here, negative 7, negative 6, negative 5, negative 4, negative 3. That should be enough. Okay, so if the y values are between and inclusive of these things, I need to draw a circle at negative 8, filled in, circle at negative 5, filled in, okay, and it's saying y is between them. Okay, so any solution in there works. All right, that's what this is saying. So here's another one. For this one, a lot of students get confused with this one, so pay close attention here. When you have something in the middle like this, what they want you to do is they want you to solve the inequality for both parts. So we're going to look at this inequality, okay? And then we're going to look at this inequality. Let's do it with a highlighter. This inequality. Okay, so you have to solve it twice here with the algebra piece. It's not too difficult, but it's kind of a weird thing because this r plus 7 applies to both the 10 and the 6. So all I'm going to do is I'm going to subtract 7 from the middle and from both sides of the inequality. Okay, so if I do that, 6 minus 7 is negative 1. Okay, and I'm subtracting 7. Notice I'm not dividing or multiplying by negative 7. Otherwise, I would be flipping some inequalities here. So I have negative 1 is less than or equal to r, which is less than 3. Okay, so I subtracted 7 from everything, and now I have this nice inequality. It says that the things that I need to graph are between negative 1, so we'll call this negative 1, 0, 1, 2, 3, 4. Okay, so between negative 1 and inclusive of negative 1, because we have the or equal to there, right? And then at 3 we have an open circle, and we're going to graph in between. The r value, or the unknown value, is somewhere between those 2 points on the graph, so that's how we show that. All right, so next, that's and inequalities. Next we have or inequalities. Okay, so how does that look individually? So if we graph an or statement individually, right, take each individual piece, this is what I'm going to show you. X is greater than 2, so if I have 0, 1, 2, open circle going this way. And if I were to graph this guy, it would be x is less than or equal to 1. So if I did 0, 1, 2 again, I would have a filled in circle here, and this one would be going this way. So with or inequalities, most often they're going in opposite directions. I think we'll do one here where it's the same direction, there's overlap, but that just means that we're looking at one of them. But typically they're going to go off in opposite directions in most cases. All right, but sometimes you'll have one that is only going in one direction. I'll try to show that to you. So here we go. Or statements, there's no way to put the variable in between. So if you have a variable in between, like we did here, that's always going to be an and statement. There's no way to do that with or statements, so it'll have to say or. Okay, so that's how you can kind of tell the difference. So here we have x is greater than 2. So let's just label this 0, 1, 2. Let's do negative 1, negative 2. X is greater than 2. Okay, so open circle here, going off this direction. Or x is less than or equal to 1. Okay, so at 1, filled in circle, because it's or equal to, and going that way. That is your answer. The graph is your answer, by the way. So just make sure that you have good pictures with good open circles, closed circles, with arrows going the right way. Okay, example 2 says a company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality that describes how tall the action figure can be. So basically it's saying, we don't want this action figure to be outside of this range of 11.2 to 11.4. Okay, so the action figure, which we can call A, all right, for action figure, has to be somewhere in between. So what does that look like? It looks like this. I have 11.2, which is less than or equal to the action figure, which is less than or equal to 11.4. Okay, the action figure has to be between those two pieces. So to graph this, I might just go by tenths. So I might just say, okay, this is 11.0, 11.1, 11.2, 11.3, 11.4, 11.5. And we're saying we're in between or, equal to those things. So I'm going to go ahead and graph that. We'll do that in blue. So we're going to start with a solid circle at 11.2, go to 11.4. Somewhere in between here is where the action figure height has to be. Okay, somewhere in between there. Example 3, here's another or. I don't know why they threw that and statement in the middle of or, but that's how your book did it. So let's do this one. We have an or statement here, a little bit of algebra. Let's solve it. So to get a by itself, we're going to subtract 1 from both sides. We have a is less than 3, or we can add 1 to both sides on this side. We have a is greater than or equal to 4. Okay, so what does that look like on a number line? I don't know why I don't give you a number line here. So we have 0, 1, 2, 3, 4, 5. I like to go a little bit on either side of whatever I'm dealing with, 3 and 4 here. So it says a is less than 3. Okay, so at 3 we're going to have an open circle. We're going to be going this way. And it says or it's greater than or equal to 4. Closed circle at 4, going off that way. All right, here's 3b, and I think this is one where it's an or statement, but I think I think I put in one here where they go just the same direction. So let's take a look at this one. Notice this one's already solved for me. So we have x is less than or equal to 9. Let's see what we get on the other side. So to get this x by itself, I have to subtract 2 from both sides, and we get 4x is less than 8. Okay, then we divide both sides by 4 to get x by itself, so we have x is less than 2. So now notice here, you guys, we have x is less than or equal to 9. Okay, so x is less than or equal to 9. Let's just put that on the graph. Here's 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, if it's less than or equal to 9, I'd have a closed circle here, and it'd be going this way. Okay, then the or statement also says, x is less than 2. Well, if x is less than 2, that's here going off in this direction. But the 9 has already included that piece, right? So we really only need this one graph of the x is less than or equal to 9 because that's inclusive of this guy. So we don't have to worry about the open circle there or anything because it's already included. We just have a solid line starting at 9 and going down. If it was going in the other direction, then we'd obviously have to have that open circle and make it go the other direction. But here, it doesn't. All right, goes the same direction. That's all for now, guys. More in class. Catch you next time.